what the difference quotient is this expression, f of x plus h minus f of x all over h. So anytime you are asked to find the difference quotient, that expression should come to mind. Once that expression comes to mind and you recognize within that expression that you've got a couple of notations here for the function, what you should be thinking to yourself is, okay, I need to basically play with this function twice, figure out the pieces I'm working with, and plug into this expression here. In other words, f of x plus h makes up the first part of this. We already found f of x plus h right here. So as I set up a new expression here to simplify further, I'm going to appreciate I'm substituting in for the function in both of these places, and all of this is over h. In the first position, I will put this f of x plus h that I found up here. So in goes 2x plus 2h minus 5. Then according to this expression, I need to subtract, and I need to subtract whatever f of x is. Well, f of x is this guy, 2x minus 5. I would subtract it as a quantity. It's got multiple terms to it. Parentheses really not necessary on this first part here, but it helps to show the substitution a little bit better. Now that I have everything set up, well, let's distribute this negative through, and let's start combining some like terms. Notice what happens. Notice the 2x's cancel out. Notice the 5's cancel out. And all we're left with is a 2h in the numerator over an h in the denominator. And this is how you can tell you're going about these problems correctly. If you are left with terms in the numerator that only have an h in there, you know you are doing this correctly. Because what should happen is that any h's in the numerator in those terms should cancel with the h in the denominator. So obviously I just have the one term with the 2h on top. If I take this h, divide this h, they cancel out. So my difference quotient, given the function as 2x minus 5 to start here, just equals 2. Okay, so we've already done the work on this one to find f of x plus h. Let's find the difference quotient now for this one. I set up my form for the difference quotient. I appreciate again that what I'm going to set up here is one big old rational expression all over h. And in the numerator portion of this, I'm going to insert in a couple of function ideas. I'm going to insert in f of x plus h. I'm going to insert in f of x. So as I substitute in f of x plus h, that's the work that I found right up here. So that goes in, I get x squared plus 2xh plus h squared minus 3x minus 3h plus 1. Parentheses not necessary, but I'm throwing it in here just to show that, hey, that's the substitution for this first part, f of x plus h. We are then subtracting. We are subtracting f of x. F of x is the original function. So the original function up here, x squared minus 3x plus 1, we put that in. We've substituted for each of our pieces here. All of that's over h. We're ready to go with the simplifying portion now. As you simplify, you carry your negative through, and you collect like terms. And like I said on the previous problem, we know we are doing this correctly if the only terms left in the numerator have h's in them. Watch what happens. X squareds go away. 3x's, they're gone. And then our constants of 1 also cancel out. You've got a 2xh, you've got an h squared, you've got a minus 3h left. All terms that have an h in there. So if I write out the leftovers, so I can see this a little bit better, it'd be 2xh plus h squared minus 3h all over h. As long as all the terms on top have an h in them, I can take this h in the denominator and I can divide into each term. So as I divide in, this h goes away. If I divide into the first term, that h cancels out. If I divide into the second term, there's 2 h's there, so now there's 1. If I divide into the last term, well, there's 1 h there, that cancels out. If you write what's left over, you have 2x plus h minus 3. So the h in the denominator always cancels out. All right, the given function is just a constant value like we have here of 7. You know, what are you going to do to find the difference quotient ultimately? As we saw in the previous two problems, it was helpful to figure out what f of x plus h was first, right? So if you find f of x plus h first, all right, think about what that means. You're taking x plus h, this variable expression, which represents a value I'm plugging into my function. I'm plugging that into my function for any x's that I see. You see any x's? No. In fact, whatever you plug into this function, whether it's this variable expression x plus h, whether it's some other number, what's the output you're always going to get? It's always going to be 7. So no matter what I plug in, I get 7 back. Which means when I come down here to the difference quotient, you're setting this up all over h. F of x plus h, that's 7. And you're subtracting f of x, which up here equaled 7. This one's not too hard, is it? Get 0 over h, which is just 0. So anytime the function equals a constant value, your difference quotient will always be 0.